Welcome to Learn Yourself. Today we are going to study about extraction of aluminium, and this topic is under Metallurgy Standard 10 under ICSE syllabus. Earlier we have seen that how we are extracting a metal. So there are four basic steps of it: dressing of ore, concentration of ore, reduction and electro-refining. All these steps we have seen separately, and we have seen that what we are processing under all these steps. I have given the link of all those videos in the description. So if you have doubt in any particular step, please go through those videos and then come back to this. Now here, dressing of ore is the first step to purify the ore of aluminium. Now which ore we are taking for aluminium? So that ore is bauxite. And what will be the molecular formula of it? Al2O3 2H2O. So this is bauxite and this is a premium ore of aluminium. So from this we are extracting aluminium. So first step is dressing of ore. Now what is dressing of ore? We are eliminating all those gangue particles, all those muddy impurities from our ore. So we are concentrating ore in first step by eliminating mud impurities or earthen impurities from the ore. Then second step is concentration of ore. This step is not required in this ore because under this step we are converting the ore into its oxide form. How we are doing it? Via calcination and roasting. But this step is not required because already our ore is in oxide form. This is aluminium oxide. So this step is particularly not required in bauxite ore because our ore is already in the oxide form. If not, if they have combined with sulfur or carbonate, then we would have performed calcination or roasting. But here we are not doing it. So from first step we will directly go to the reduction. What is reduction? Reduction is from oxide of ore we will get a metal, that is aluminium. So from oxide we will reduce it and we will get aluminium. How it is reduction? Because aluminium is going to separate from oxygen. Where there is elimination of oxygen, that is termed as reduction. So this is reduction reaction and this step is reduction. Then fourth is, this step is required only and only if we require a very purified form of metal. If 99% and above purification is required for any metal, then we will go with electro-refining. Now what is electro-refining? We have already studied this in chapter 5. So I have given that video link as well in the description, or you can just check the website under the ICSE Standard 10. You will find that in electrolysis chapter, or you can just see the playlist. Okay, so electro-refining we will perform if we require ore above 99% pure. So all this is just a highlight, just an overview that how we are extracting aluminium metal. Now we are going to see in detail all these three steps, and we will see that how we are extracting aluminium from its ore, that is bauxite. So let us understand how we are extracting aluminium. So this is the first step, the dressing of ore. This process is also known as Bayer's process or Bayer's process. In this process we are doing dressing of ore, and this first step of the extraction of aluminium has three different steps. So first step we will just understand it, what we are doing it, then second step and third step. Along with this I am covering the reason also that why we are doing so and what will happen if we are following this chemical process. So first step is, this is our bauxite ore, this is our ore, Al2O3 2H2O, this is our ore. When it is reacting with caustic alkali or NaOH, sodium hydroxide, at 150 to 200 degrees Celsius, we will get NaAlO2. This is sodium aluminate. Name of this molecule is sodium aluminate, and water will be separated out. So in this step, what we are doing, impure bauxite we are converting into sodium aluminate, and what we are doing and why we are doing this, because in this ore there are two types of impurities. First is iron oxide, iron 3 oxide, Fe2O3. Now how will you check that whether this is iron 2 oxide or iron 3 oxide? From oxygen. So to understand this, we have to see the crisscross method of molecular formula. If iron's valency is 3 and oxygen is 2, then only oxygen will carry 3 with it. So if oxygen is carrying 3, then this is iron 3 oxide. If oxygen is carrying 2, then this is iron 2 oxide. That is how we will identify that whether this is iron 2 oxide or this is iron 3 oxide. Now coming back to our point that in impure bauxite there are two kinds of impurities. First is Fe2O3 and second is SiO2. This is silicon dioxide and this is iron 3 oxide. So these two impurities are there. And what is our bauxite? That is Al2O3 twice H2O is amphoteric oxide. Now what is the meaning of amphoteric oxide? The oxides, when it is reacting with acid or alkali, they will give salt and water. Those oxides are known as amphoteric oxide. Now what are the alkalis? Base which are soluble in the water are known as alkali. So when this oxide will react with base or acid, what they will give? They will give salt plus water. So here we are going to react our ore with base. So what we will get? We will get salt, and we will get salt of our aluminium. Now these two impurities are not amphoteric in nature, so they will remain as it is. They will not react with acid or base. Acid or alkali, they will not react. So they will remain as it is, whereas our aluminium will form salt and it will separate out. So in extraction process we can do two things. First, either you separate out the impurities or you separate out a metal in any other form. So here what we are doing, we are not treating impurities. What we are doing, we are treating our oxide and we will convert it into a salt form and we will extract it. So this is the first step of Bayer's process, in which we are converting our impure bauxite to sodium aluminate. And why it is happening? Because this oxide is amphoteric oxide, so it will react with base and it will give us salt. What is the name of salt? Sodium aluminate, and it will generate water. So our impurities will remain as it is and we will take out our salt. Now moving towards our second step. In which this sodium aluminate, we are diluting it with water and we will heat it at 50 to 60 degrees Celsius and we will get insoluble aluminium hydroxide. So how we are separating insoluble aluminium hydroxide? We will further dilute it, and what we will do? We will add crystals of aluminium hydroxide to that solution. Some crystals of aluminium hydroxide we will add to that solution. And with the process of seeding, we will separate out this aluminium hydroxide in the crystal form. This seeding process we have studied in standard 9 in the chapter water, where we are find out that how to generate a crystal with the method of seedling of crystal, in which we are hanging one crystal in the solution and we will get a crystal of copper sulfate. That video's explanation link I have given in the description. If you want to check the seeding process, you can check this description. So with the process of seeding, we will get a crystals of aluminium hydroxide. So in this step what we are doing? We are doing hydrolysis. So in this hydrolysis step, we will get sodium hydroxide and aluminium hydroxide. This aluminium hydroxide will precipitate out in the form of crystal. Now this is second step. Now moving towards third step. So third step, in which we are filtered out those crystals of aluminium hydroxide and we will heat it at 1100 degree Celsius. So we will get Al2O3. This is our pure alumina, and this is the first step in which we are separating all the impurities, earthen impurities from our main ore, and this is in the form of oxide. So till now we have covered only first step, and that is dressing of ore. In this we are converting our ore into concentrated form by removing all those earthen impurities. In this step we have eliminated iron 3 oxide, silicon dioxide and some other impurities, and after that, after 3 chemical reaction, we got a pure alumina. And now we are not following second step. What is the second step? Second step is to convert our ore into oxide form. But our ore is already in the oxide form. So we are skipping step 2, that is concentration of ore. We are skipping that second step and we are going to a reduction. So directly from this we will get aluminium, and we are reducing this pure alumina to aluminum. The third step we have skipped second step in between because our ore is already in the oxide form. So this is the third step. We are reducing pure alumina to metallic oxide. Now this process is also known as Heroult's process. In this electrolytic reduction, we are taking this electrolytic cell in which cathode we have taken a lining inside a electrolytic cell. Whatever lining we have done is of gas carbon lining, and that gas carbon lining itself will act as a cathode. Now anode. These are the anode rods and they are of carbon. So there are 7 carbon rods we have taken, and they will act as anode in this electrolytic process. As an electrolyte we have taken 3 different things, and that too in different proportion. Fused alumina. Now what is the meaning of fused alumina? The molten form of alumina. And what is alumina? Alumina we have recovered from the bauxite ore that we have already seen in first step. So this is alumina, that is Al2O3. Earlier it was Al2O3 twice H2O. That was our bauxite ore. Here we are using Al2O3, that is our pure alumina, and that we are taking in fused state. That means it is in the molten form. That we are taking one part. Then cryolite we are taking. What is cryolite? Cryolite is Na3Alf6. This compound name is cryolite, and that we are taking in 3 part. Then feldspar also we are taking, that is CaF2 in 1 part. So all this mixture we are taking as electrolyte. Now why we are taking all those compounds? There are different benefits of this that we will discuss in detail when we are discussing reasons. Here I am telling you 2 main things. That first, it will lower down the temperature at which the alumina will become fused, or it will convert to the molten state. When we are adding this mixture, it will melt at the temperature of 950 degrees Celsius. So this is the first advantage, and second advantage is it enhances the mobility of this fused mixture. So we will discuss all these things in detail when we will discuss the reasons. So here first we will discuss how this cell will work. So cryolite, feldspar and alumina, when these 3 are there in electrolytic solution, how they will dissociate. So cryolite will dissociate in Na plus Al 3 plus 6F minus. Then feldspar will dissociate into Ca plus 2 and F minus, and alumina will dissociate into Al plus 3 and oxygen 2 minus. So all those ions will separate out, and all those ions will be there in our electrolytic medium. So what will happen in this electrolytic process? We are doing a reduction, and we have taken anode rods, carbon rods. So with the help of this carbon we are doing this reduction process. So Al2O3 will convert into molten aluminum. So with the help of this carbon rod, this reduction will happen, and this is molten aluminum, this is pure aluminum will comes out from the bottom of the electrolytic cell, and that we are collecting over here. So this is the process of electrolytic reduction. What will happen at cathode? At cathode, aluminium ion will discharge and form pure alumina, and that we are collecting it from the bottom of the electrolytic cell. At anode, oxygen will get discharged and it will give us one atom of Nessel oxygen. So here all those Nessel oxygen will combine and form oxygen gas. So at anode we will get oxygen gas, some of the amount of carbon dioxide and carbon monoxide as an impurity, but that will be liberated out. Now our important product is aluminum, and that will be in the molten form. Why it is in the molten form? Because this electrolytic reductions temperature is very high. So whatever metal we will get, that metal will be in molten form, and that we are collecting from the bottom of the electrolytic cell. So in this you have to remember that what proportion we are taking electrolytic solution, then how those electrolytes will get dissociate. So this three equation and two more equation, that what process will happen at cathode and at anode. So what products we are getting at cathode and at anode. At cathode we will get our product, that is molten aluminum, and at anode we will get a gaseous product, that is oxygen. Earlier we have seen the complete process, that is Heroult's process. Now here we are discussing the reasons. First reason is why we are choosing electrolytic reduction instead of simple chemical reduction, that we are doing it for other metals, that simply we can let them react with carbon and oxygen will separate out, but that won't be possible in the case of aluminium oxide. Why? Because aluminium oxide is highly stable oxide, and aluminium has high and strong affinity towards oxygen. So this is very stable compound, and it is not possible to break it down or decompose it or to separate aluminium from the oxygen with simple chemical reaction. So that's why we are performing electrolytic reduction, and we will separate the aluminium metal from the oxygen. So this is very important reason that why we are performing electrolytic reduction. Then second, this process is very difficult. Why? Because first of all, the fused Al2O3, what is the meaning of fused? The molten state of aluminium oxide is almost non-electrolyte, and its melting point is as high as 2050 degrees Celsius. So if you want to melt it, you need to achieve this much high temperature. So you need a high power consumption cell, and you need to set up such a way it won't catch fire, and a high voltage battery also will be required. And at such a high temperature, the large amount of electricity is required. That is the first thing. And second thing is, aluminium metal, what we are extracting, will achieve a temperature as high as 660 degrees Celsius. So at this temperature, it tends to volatilize out, and it may get wasted. After doing so much things, and we are investing so much in the process, and at the end if the metal will volatilize out and it will get wasted, then it is of no use. So that's why this process is very complex. So that's why we are lowering down the temperature of this electrolytic cell medium. How? We are discussing that in the third reason. Third reason. This reason is very important and frequently asked in as a reason or as MCQ or in the 1 mark question, that why we are adding fused cryolite and feldspar in the electrolytic mixture. So first, there are 5 points. First thing is, it lowers the fusion point of mixture. So it lowers down the temperature at which the aluminium will become molten. So from temperature 2050 degrees Celsius to, it will lower down till 950 degrees Celsius. It also enhances the mobility of the mixture, acting as a solvent. So fused alumina will get more mobility, and it enhances the rate of reaction also. So this will act as a solvent. Then next is cryolite. This point is only for the cryolite, that cryolite will enhances the conductivity. Because earlier we have seen that Al2O3 is almost non-conductor of electricity. So here it will enhances the conductivity. Then Charles Halls, who was the scientist who discovered this mixture, that if we are adding this mixture into this electrolyte, then this process will become simple. Then molten point or fusion point can be lowered down till 950 degrees Celsius, and because of this discovery, this process has become simple and cheaper. So this credit has gone to Charles Hallsbrook, scientist, and he has discovered that we can use the mixture of cryolite and feldspar to solve all the difficulties faced by this electrolytic reduction of aluminum. Our next reason is the layer of powder coke will sprinkle over the electrolytic mixture, that we are sprinkling some powder coke over the electrolytic mixture. Why we are doing that? Because it prevents the burning of carbon rods. We know that this process we are doing at high temperature. So we should prevent the burning of carbon rods. Where are the carbon rods? These anodes are carbon rods. So it will prevent the burning of those rods, and second is it minimize or prevent the heat lost by radiation. We need to maintain that heat in this electrolytic medium because we want our alumina in the molten state or fused state. So this heat should not escape out. So once we are sprinkling the powder coke, it helps us in two ways, that it will prevent the burning of carbon rod, and the second thing is the heat will not escape out, so that we can maintain that temperature. Then fifth one, carbon rods or anodes should be continuously replaced. Why is it so? Because oxygen evolved at anode will react with carbon. We know that whatever oxygen is evolved at anode, the product is oxygen. That oxygen will evolve and immediately it will react with this carbon rod. And since we are getting the carbon dioxide and carbon monoxide, so this is in this continuous process, oxygen is continuously reacting with this carbon rod. So they will diminish in the mass and it will get consumed. Carbon rod will get consumed. So we need to renew it, or we need to replace it time to time whenever they will become thin. So because of this oxygen, and this oxygen will react with this carbon rod, it will diminish in mass, it will get consumed, and that's why we need to replace them. But next reason is this process is a continuous process. So why this is a continuous process? Because a pure aluminium, alumina is Al2O3. What is alumina? Alumina is Al2O3. Aluminum oxide is also known as alumina, and pure aluminium is our aluminium metal. So here pure aluminium is heavier and settle down, and we can take it from the bottom. As the aluminium will separate out from the aluminium oxide, it will settle down here in the molten state, and that we can take it out from the bottom of the electrolytic cell. Now when the concentration of alumina, that is Al2O3, will falls down, here we have attached one control lamp. So the resistance of the bath will increase because the molten alumina's concentration has lowered down. So because of that, the resistance of the bath will increase, and this will be indicated by a glow on control lamp. So once this bulb will glow, it will notify us that concentration of Al2O3 has been reduced. So we can add some more Al2O3 or alumina into this electrolytic cell, and again this process will start. So that's why this process is a continuous process, and through this process we can achieve 99.5% purity of aluminium metal. This further can be purified and can achieve 100% purity of aluminum metal by Hooke's process of electro-refining. So here we have discussed that why this process is continuous. So once the concentration of alumina will become lower, at that time the resistance of the bath will increase, and this bulb will glow and show us and indicate us that the concentration of alumina has fallen down. So we can add some more Al2O3 or alumina into the electrolytic cell, and again this process will start. So this is all about the extraction of aluminum, and we have seen the two main processes, Hall-Heroult's process of electrolytic reduction, and earlier we have seen the Bayer's process of dressing of ore of alumina ore. All other videos link I have given in the description. If you have doubt in any of the step or any of the process, please comment down below. Don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep practicing.